Well, voltage, really the electron flows through a piece of them. Electrons don't know whether they're AC or DC, they just flow, okay? And the piece of wire really doesn't know whether they have AC or DC, it's just a piece of wire. The drop depends on what? On the length of the wire, the area, and the resistivity of the wire itself, the resistance of the wire itself. So actually, the longer the length, and the longer the length of the wire, it will increase the resistance. So therefore, the actual voltage drop depends on the length. So typically, you like to keep your lengths as short as possible. Now, there are reasons why would you, reasons. Some of the people that will put in the inverter right on the roof, some make it accessible. Some people will put the inverter right into the actually next actually to your service equipment. There are some utility requirements that you must have a disconnect before the actual utility meter, so they can remove that. This is part of the requirements that you have to meet when you actually read the rules of interconnecting to the utility. Some utility companies, ideally most of them now, they are reading next to the inverter, is usually mostly next to the actually meter, the utility company. However, I've seen stuff, installations that they have the inverter. Really, actually, they install all the pieces of the electrical equipment right, sometimes underneath the panels itself. So they put a box up there, board up there, and they install everything right up there. So they have done that. Yes, sir.
It's similar to the panels, just the SNG, not all poles, everything's self-contained, and really working the street light with that. Not just grid, it's opening up the grid.
Yeah.
Stars, isn't it?
Yeah.
It's all feeding grid.
So, and usually you see the inverters, there's a lot into the inverters. You usually classify them, it's either the battery backed base type or the utility interactive. Most of them, or both, most of them that you guys are going to be dealing with, it's actually utility interactive. I've seen very few standalone systems unless you have like the ones that they do now for the telephone poles and so forth. There's a lot of stuff, there's a lot of electronics, because we call them that power conditioning units, because besides doing the inversion, they do a lot of other things. They use charge controllers, they have built in within the inverters and so forth. So, but their main function is actually taking DC power and actually changing to AC. Don't forget, a lot of them, you see one of the biggest problems was actually the inverters going bad, actually burning it up. Sometimes in the early days, the inverters will get hit on the sun, a lot of excessive temperature built up, a lot of the components, because you're dealing with a lot of electronic components up there, so they were damaged. Okay, charge controllers, if you have any kind of a system that you have to use what? Batteries, you have what? A charge controller. All it does, it's not simple, it just regulates the battery charge by doing what? By controlling the actual voltage that you put what? From the array into the actual battery itself. Very similarly to what you have in your car. What do you have in your car? You have a regulator in your car, right? As your alternators, or your alternator generates what? The output of the voltage up there. Sometimes the voltage what? Fluctuates up and down. It regulates the amount of voltage that goes into your battery, so therefore you don't accidentally what? Burn your battery. Very similarly, yes?
You not have the batteries and sell the power back to the
Yeah.
Either or. You can either have the batteries and store power or sell it back to the
The question is, can you have a combination of both, you say?
Or that.
Yeah, can you have a combination?
Either or both.
You can have a standalone system, just a battery system. You can, as I go through it, you can see types of systems and types of connections that I have. But the question was, can you have either or? And the answer is yes. not only you can have either or, but you can have a P system, you can have a wind system, a standby generator connected to it. You can have all kinds of bells and whistles associated. And manufacturers, like some of the inverter manufacturers, they looked at these things and they said, listen, maybe we can have an inverter that we can plug a wind system and you know, generator system, or we can plug in a generator there, so this way you can play with that. And they have done things like that. Yes?
In your opinion, being the educated man that you are,
I'm not that educated, but that's okay. Go ahead.
How long do you feel it will be LED lights on a 12-volt system running our entire house?
What does that do with solar?
I don't know.
What does that do with what?
I don't know that answer.
What does that have to do with
Because if you put it in the solar panel and you have a battery backup, you have 12-volt systems that you could do in anything.
Well, I don't know the answer to that, but I'll look it up. Maybe next week I might have something. I don't know. I really don't know much about that.
I mean, LED lights are the thing of the future.
I don't know the answer to that. I don't know. But listen,
Stupid question, I'm sorry.
it's there's, you know what it is. We're talking about flat panel collectors and the associated equipment that deals with them in a typical, because we're not really talking about sophisticated, you know, solar panels. So there's a lot of research is done in everything. I mean, there's research done in actually applying paint and turning into solar panels. So so it's a different thing. We talk again. Let's not guys. Let's not get off the function again. It's important. Here's what's going to happen, guys. You're going to get somebody who's going to tell you, I need a solar system that just to power a light in my shed or something specific, and you're going to need to size it, put a charge control, and so forth. You have to know that you need that, so you have to pay a little bit of attention. The charge control, it doesn't only charge, but it's also what? Protects the battery for what? Overcharging and over discharging. Or what happens if you over discharge a battery? Okay. Remember, these systems are not cheap. You screw up, you're going to pay for it. If you're not going to pay for it, you're going to be face yourself in the front of a lawyer, and believe me, a lawyer knows everything that it is to know about what? Photovoltaic systems. Because they know two answers, yes or no. Trust me about that, okay? So there's a lot more in the charge controller than just to charge and discharge a battery. So there's a lot of the housekeeping for the battery, okay? And there's many different kinds of it that is available. All the things that you're dealing with: rectifier, chargers, and converters. A lot of us, where's a rectifier? Rectifier does what? Converts AC to DC. Okay. A typical thing like a windmill. What is really a windmill? What do you have in a windmill, for example? You have a little propeller up there and it drives what? A generator. What do you get out of a generator? AC, right? What do you get out of a generator? AC. Now what happens now if you get that AC up there? What are you going to do? Put it on your grid? What do you do with it? How do you condition it? How do you condition its frequency when sometimes the wind is 50 miles an hour and sometimes it's 10 miles an hour? And you have some blades that are about 200 feet apart. So there's a lot, the fluctuation of the voltage as well as what? As the frequency and all these things goes berserk. So you need to do some smart things. So if you have one, let's say, installed by Constantine in the side of your house, you're going to say, what is this thing going to do? So you have to figure some way, some little device to figure out how to do it. I mean, after all, you get paid as a big electrician to do this fancy job, a lot of money. So you say, well, I got two options. I can either do what? Get a rectifier, do what? Take AC, change it to DC, and then do what? Take the DC now and do what? Change it back to AC, so now I'm matching what? The utility company's method. Or do something else. So usually, that's why you need